Hello students, in this video we will discuss principal values of cos inverse of cos x. But before that, consider function fx is equal to cos of cos inverse x, so that we do not get confused between this function and cos inverse cos x function. First of all, what is the domain of this function? For which values of x this function is defined. Now here we have cos function, and cos function is defined for all real values of angles. आप cos function के अंदर कोई भी angle रखो, it is defined. But cos inverse x is defined only for x belongs to minus 1 to 1. That means domain of the function is minus 1 to 1. Okay, now what is the range of the function? For this values of x, cos inverse x will give values between 0 to pi. And for angles 0 to pi, cos will return values minus 1 to 1. आप यहाँ पे cos inverse x में x को लेंगे minus 1 to 1 के बीच में, जिसके लिए cos inverse x का वैल्यू क्या होगा? 0 to pi होगा. और फिर 0 to pi एंगल्स के लिए जो फर्स्ट एंड सेकेंड क्वाड्रेंट में है, उसके लिए cos थीटा का वैल्यू क्या होगा? minus 1 to 1. That means range of this function is minus 1 to 1. This is a function of the form g of g inverse x. We write like this, g o g inverse x, and this is always x for x belongs to domain of function. For example, if I take x is equal to half, so I have cos of cos inverse half. What is cos inverse half? This is pi by 3. So cos pi by 3, this is equal to half. So I am taking here x is equal to half, I am getting half here. You can process some more values, say cos of cos inverse 1. What is cos inverse 1? It is 0, because cos 0 is equal to 1. So we have here cos 0 and this is equal to 1. So I am getting here 1 for the pre-image 1. Take one more value, cos of cos inverse, say minus root 3 upon 2. Cos inverse minus root 3 upon 2. That means this angle will lie in second quadrant. And in second quadrant, the angle will be 5 pi by 6, because cos 5 pi by 6 is minus root 3 by 2. So here we have cos of 5 pi by 6, and this is equal to minus root 3 by 2. Again we are getting the same x which is here. That means cos of cos inverse x is equal to x, but not for all real values of x, for values of x which are lying in the domain. For all x belongs to minus 1 to 1. So suppose if we want to draw the graph of this function, how we draw the graph? Okay, now some students do this way. They consider this function as y is equal to x and they draw line y is equal to x, but this is not the full line y is equal to x. This is the part of that lying between minus 1 to 1. So here we have minus 1, here 1, this is 1, this is minus 1. So here we have point minus 1 comma 1 and 1 comma 1 here. So we draw line like this. Okay, so this is in fact not a line, this is a line segment. ये ग्राफ में सिर्फ इतना पार्ट आएगा, पूरा स्ट्रेट लाइन नहीं आएगा, ठीक है? In which these two endpoints are also included. Now consider function fx is equal to cos inverse of cos x. So let's consider function fx is equal to cos inverse of cos x. First of all, what is domain of the function? क्या arguments होंगी domain निकालने के लिए? Here we have cos inverse function which is defined for arguments lying between minus 1 to 1. Cos inverse function के अंदर जो values हैं, जो arguments हैं, वो कहाँ पे होना चाहिए? minus 1 to 1. So cos x must lie between -1 to 1 and it is always cos x का values तो -1 to 1 में होता ही है. For which values of x? For all real values of x. So the domain of function is all real numbers. एक बार फिर से देख लेते हैं हमने किस तरह से आर्ग्यूमेंट्स किया. Cos inverse function is there. Inside function is cos x. Cos inverse function defined for arguments -1 to 1. So cos x must lie between -1 to 1, which is the actual range of cos x function for the domain all x belongs to R. So the domain of this function is R. What is the range of the function? Range of the function depends on the values of cos x. Cos x lie between -1 to 1, and for this values -1 to 1, cos inverse will return values between 0 to pi, including 0 and pi. We can write this way. For x belongs to R, cos x belongs to -1 to 1, and for cos x belongs to -1 to 1, cos inverse of cos x belongs to 0 to pi. So the range of the function is 0 to pi. Domain is R and range is 0 to pi. In previous case, both domain and range were -1 to 1, but here we have a bit different situation. Okay, now let's take some values of x here and get the values of cos inverse cos x. Consider cos inverse of cos of pi by 3. What is cos pi by 3? Cos pi by 3 is half, and cos inverse half is equal to pi by 3. So here we are getting the value pi by 3, which is same as input x is equal to pi by 3 in the domain. Consider this value, cos inverse of cos of say 5 pi by 6. What is cos 5 pi by 6? This angle lies in second quadrant. The value of this is minus root 3 upon 2, and cos inverse minus root 3 upon 2 is 5 pi by 6, because here we have negative argument, so we will consider angle in second quadrant. The range of cos inverse function is 0 to pi. Okay, so when we have here negative value, negative argument, we will consider angle which is lying in the second quadrant from pi by 2 to pi, where we get this angle 5 pi by 6. Take one more value, cos inverse of cos of say 3 pi by 4. Cos 3 pi by 4 is minus 1 upon root 2. Okay, and cos inverse minus 1 upon root 2 is 3 pi by 4. So again here we are getting the same value in the range, which is equal to value in the domain. But if we consider this values, say cos inverse of cos of 7 pi by 6. What is cos 7 pi by 6? This is cos pi plus pi by 6. The angle is lying in third quadrant. So this is cos inverse of, the value of cos 7 pi by 6 will be minus root 3 upon 2. And cos inverse minus root 3 upon 2, we are considering the principal values. The range of this function is 0 to pi. So we must get the angle which is lying between 0 to pi. This is negative, so we will consider angle of second quadrant. ऐसा कौन सा एंगल होगा जिसके लिए cos का वैल्यू minus root 3 upon 2 होगा? That angle will certainly lie in second quadrant where cosine function is negative. So this value is 5 pi by 6. So what is change here? The change is here we are getting the value which is not equal to the input. The input is 7 pi by 6 and we are getting answer 5 pi by 6. But here in all these three cases we have output which is same as input. Similarly, if I consider this one, cos inverse of cos of say 19 pi by 3. Okay, now 19 pi by 3 is not the answer. Okay, the reason is 19 pi by 3 does not belongs to 0 to pi, which is the range of cos inverse function. जैसे हमने यहाँ पे देखा, why this value is not 7 pi by 6, because 7 pi by 6 does not lie in the range of this function. cos inverse का range क्या होता है, 0 to pi होता है, जिसमें ये एंगल नहीं आया, तो फिर यहाँ पे वैल्यू क्या आ रहा है, 5 pi by 6, which is actually value belongs to 0 to pi. So this is not 19 pi by 3. So how we calculate this? 19 pi by 3, I can put this as like this, 6 pi plus pi by 3. What is cos 6 pi plus pi by 3? This angle will lie in first quadrant. 6 pi पे आए, फिर हम एंटी क्लॉकवाइज जाएंगे, pi by 3 एंगल, तो हमें एंगल मिलेगा फर्स्ट क्वाड्रेंट में. इन फर्स्ट क्वाड्रेंट cos pi by 3 is half. So this is cos inverse half, and cos inverse half is pi by 3. So here input is 19 pi by 3, but output is pi by 3. From these values we can say that cos inverse of cos x will be x only if x belongs to 0 to pi. That is principal value branch. We can write this way: cos inverse of cos x, this is equal to x for all x belongs to 0 to pi. ये x तभी होगा जब x कहाँ पे होगा, 0 to pi, which is the principal value branch of cos inverse function. If x does not belongs to 0 to pi, then certainly this is not equal to x. The value will be different, but not x. So the most important concept in this discussion is that cos inverse of cos x is equal to x for x belongs to 0 to pi only. Now let's find principal values of cos inverse of cos x when x is in the form of radians. Consider this one, cos inverse of cos 1. What is the value of this? Here 1 is in radians. Now the range of cos inverse function is 0 to pi, that is 0 to 3.14, and this one lies in this 0 to pi, so straight away value is 1. What is the value cos inverse of cos 2? क्या होगा इसका value? Again here we have 2 radian which lies in 0 to pi, so answer is 2. Every time if we have here value which is lying in the interval 0 to pi, we will get the same value here. Then we consider cos inverse of cos 3. This 3 lies in 0 to pi, so the value is 3. Now consider cos inverse of cos 4. Can I write 4 here? Definitely not. The reason is 4 does not belongs to 0 to pi. This does not belongs to 0 to pi. So this is not equal to 4. Then what will be the value? For that we will adjust this angle using integral multiples of pi. Now let's modify this angle. So we can write this way, cos inverse of cos of pi plus 4 minus pi. This is theta. What is cos pi plus theta? Cos pi plus theta is minus cos theta. So this is equal to cos inverse of minus cos 4 minus pi. And what is cos inverse of minus x? Cos inverse of minus x, this is equal to pi minus cos inverse x, for x belongs to minus 1 to 1. What is the proof of this? We consider angle theta. Suppose this is theta. So theta belongs to 0 to pi and x belongs to minus 1 to 1. So I have cos theta is equal to cos of cos inverse of minus x. And what is cos of cos inverse minus x? Straight away this is equal to minus x, but x belongs to minus 1 to 1. अभी हमने देखा था कि cos of cos inverse x क्या होता है? x for all x belongs to minus 1 to 1. Here we have minus x, so I am getting here minus x. So we have now x is equal to minus cos theta, and I can write minus cos theta as cos of pi minus theta. Now what is the reason of writing this way? Why not pi plus theta? Why not 3 pi plus theta, 3 pi minus theta? Because all these values are equal to minus cos theta, but why only pi minus theta? The reason is that theta belongs to 0 to pi, so minus theta belongs to minus pi to 0, so pi minus theta belongs to 0 to pi. Now these are the principal values of cos inverse function. What is the advantage of this? If I take here cos inverse, so I have cos inverse x is equal to cos inverse of pi minus theta. Now I can write this is equal to pi minus theta because pi minus theta belongs to 0 to pi. What is the aim? टारगेट क्या होता है? यहाँ पे हमें इस तरह से एडजस्ट करना है जिससे जो ये एंगल है वो cos इनवर्स फंक्शन के प्रिंसिपल वैल्यू ब्रांच में आ जाए, ठीक है ना? जिससे मैं यहाँ पे स्ट्रेट अवे cos इनवर्स ऑफ cos x इज इक्वल टू x यूज कर सकूं, वेर x बिलोंग्स टू 0 to pi. Here pi minus theta belongs to 0 to pi, so this is straight away pi minus theta. So I have theta is equal to pi minus cos inverse x, and theta is cos inverse of minus x. So this is the proof of this statement. Okay, now using this here, this is equal to pi minus cos inverse of 4 minus pi, and cos inverse cos 4 minus pi is 4 minus pi because 4 minus pi, this value belongs to 0 to pi. So this is pi minus 4 minus pi. This is equal to 2 pi minus 4. We can get this answer straight away from here if I write this as cos inverse of 2 pi minus 2 pi minus 4. And what is cos 2 pi minus theta? It is cos theta. So this is cos inverse of 2 pi minus 4, and 2 pi minus 4 is 6.28 minus 4, 2.28, which lies in 0 to pi. So this is equal to 2 pi minus 4. In principal values of cos inverse of cos x, when x angle is in terms of radians, we always have even integral multiple of pi. Cos inverse cos x की जो principal values है वहाँ पे हमेशा pi का even integral multiple reflect होगा. Let's take some more values. What is cos inverse of cos phi? This is not phi because phi does not belongs to 0 to pi. We can write this as cos inverse of 2 pi minus 2 pi minus phi, and this is equal to cos inverse of 2 pi minus 5. Okay, because cos 2 pi minus theta is cos theta, and 2 pi minus 5 is a positive value 1.28 which lies in interval 0 to pi. So this is 2 pi minus 5. Next is cos inverse of cos 6. This is also like this 2 pi minus 6 because still this difference is positive. Because the range of cos inverse function is 0 to pi, in which we have only positive values. Okay, but if we have cos inverse of cos 7, is answer 2 pi minus 7? No, because 2 pi minus 7 is negative value. So we write this as 7 minus 2 pi. जैसे मैंने आपको बताया कि cos इनवर्स cos x की जो प्रिंसिपल वैल्यू है उसमें हमेशा क्या रिफ्लेक्ट होगा, इवन इंटीग्रल मल्टीपल ऑफ पाई, बिकॉज वी कैन राइट this way. Cos inverse of cos of 2 pi plus 7 minus 2 pi, and cos 2 pi plus theta is cos theta. ठीक है, so this is cos inverse of cos of 7 minus 2 pi, and this is equal to 7 minus 2 pi, 7 minus 6.28, which is 0.72, which lies in the interval 0 to pi. तो cos इनवर्स cos x जो फंक्शन है उसके प्रिंसिपल वैल्यू में क्या करना है, आपको हमेशा इवन इंटीग्रल मल्टीपल ऑफ पाई का हेल्प लेना है. जो यहाँ पे आंसर आएगा उसमें क्या इंश्योर करना है, द आंसर मस्ट बी पॉजिटिव. फ्रॉम 6 to 4 we have 2 pi minus 6, 2 pi minus 5, 2 pi minus 4, because these differences are positive. But for 7 I have 7 minus 2 pi because this difference is positive. For example, we have now cos inverse of cos 8. Straight away answer is 8 minus 2 pi, because still this difference is in the interval 0 to pi. What is cos inverse of cos 9? This is again 9 minus 2 pi. Now what is cos inverse cos 10? Is this 10 minus 2 pi? 10 minus 2 pi is certainly a positive number, but this value does not belongs to 0 to pi. So this is not equal to 10 minus 2 pi. 2 pi यहाँ पे हमारी हेल्प नहीं कर पा रहा है, तो अब हम यहाँ पे किसका हेल्प लेंगे? We will take help of 4 pi. So the answer will be 4 pi minus 10. Why not 10 minus 4 pi? Because that will be negative value. 4 pi is 12.56 minus 10, 2.56, which lies in the interval 0 to pi. So we can see that in each value we have even integral multiple of pi. For example, we have one bigger angle, say 100 radian. Straight away, what is the value of this? We will consider even integral multiple of pi, which is close to 100, and that is 32 pi. And you can calculate 32 pi is more than 100. So the answer is 32 pi minus 100. To ensure that this value is positive, because the range of cos inverse function is positive. Take one more, one last one. What is cos inverse of cos of 20? 20 के नियर पाई का कौन सा इवन इंटीग्रल मल्टीपल होता है? We have 6 pi, because 6 pi is 3.14 multiplied by 6, it is 18.84. So what is the answer? 20 minus 6 pi or 6 pi minus 20? The answer is 20 minus 6 pi, because this difference is positive. So now we are comfortable in finding the principal values of cos inverse of cos x for any value of x. Now let's draw the graph of this function. Let's draw the graph of function fx is equal to cos inverse of cos x. Now here inside function is cos x, which is periodic. The period of cos x function is 2 pi. So cos inverse of cos x is also periodic with period 2 pi. Cos x function की वैल्यू हर 2 pi इंटरवल के बाद रिपीट होती है, तो cos इनवर्स cos x की वैल्यूज भी हर 2 pi इंटरवल के बाद रिपीट होंगी. That means period of this function is 2 pi. Period is 2 pi. What is the use of this? We will draw the graph of this function for interval 0 to 2 pi, and then we will repeat the graph. Periodic function का ग्राफ क्या होता है? रिपीट होता है ना, ठीक है. By doing that way, we are actually reducing our job. So let's start the graph. Here we have a coordinate axis. Okay, we will draw the graph for interval 0 to 2 pi. This is 0, this is pi, this is 2 pi, next is 3 pi, here we have 4 pi. Let's put some values here. Okay, first of all, this is equal to x. This is x when x belongs to 0 to pi. हम already ये कर चुके हैं. This is one of the properties. So we have a graph y is equal to x for this interval. At x is equal to pi, the value is pi. So we have here height pi. Here we have a point pi comma pi. I join these 2 points 0 comma 0 and pi comma pi. This represent part of the straight line y is equal to x. Because for x belongs to 0 to pi, fx is x. So we have a straight line y is equal to x. Now consider this interval pi to 2 pi. X belongs to pi to 2 pi. When x belongs to pi to 2 pi, these values are not equal to x because these values are not lying in the principal value branch. Cos inverse function का range 0 to pi होता है, तो यहाँ पे जो भी आप input डालें, output क्या आना चाहिए 0 to pi. But input is pi to 2 pi, then certainly answer is not x. So what we do, we adjust this angle. We write this angle as 2 pi minus 2 pi minus x. What is cos 2 pi minus theta? This is equal to cos theta, that is cos 2 pi minus x. Now x belongs to pi to 2 pi, so minus x belongs to minus 2 pi to minus pi, and if I add 2 pi here, so 2 pi minus x belongs to 0 to pi. So we can say this is equal to 2 pi minus x. That means when x belongs to pi to 2 pi, cos inverse of cos x will be equal to 2 pi minus x. मैंने आपको कहा था ना, cos inverse function की जो principal values है उसमें हमेशा क्या आता है, even integral multiple of pi. What is straight line 2 pi minus x? It is like this. When x is equal to pi, 2 pi minus pi is pi, so we have a point here, and when x is equal to 2 pi, value is 0. So this is the graph of cos inverse cos x in the interval 0 to 2 pi. Period of this function is 2 pi. Then how you draw the graph for other values of x? We will repeat this graph. पीरियोडिक फंक्शन का ग्राफ रिपीट होता है ना, तो हमने क्या किया, एक इंटरवल के लिए ग्राफ ड्रॉ कर लिया, ठीक है, फिर हम ग्राफ को रिपीट कर रहे हैं like this. It will go up to minus infinity to this side and up to infinity on right hand side, because the domain of function is all real numbers. So we have this graph for all real values of x. The range of function is 0 to pi, so we can see that the graph is lying between limits 0 to pi. यहाँ पे domain range सब कुछ reflect हो रहा है, ठीक है ना. Also we have a sharp turns here, 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 where function is non-differentiable. The meaning of non-differentiability, we cannot draw a unique tangent. आप यहाँ पे एक यूनिक टेंजेंट नहीं ड्रॉ कर सकते ना. जहाँ पे भी शार्प टर्न आता है वो पॉइंट क्या होता है, पॉइंट ऑफ नॉन डिफरेंशिएबिलिटी, वेयर डेरिवेटिव ऑफ फंक्शन डज नॉट एग्जिस्ट. वी कैन से दैट x is equal to n pi. This are, where n belongs to z, these are points of non differentiability. Also this line is y is equal to 2 pi minus x. This line is equal to y is equal to x minus 2 pi. Slope is 1 and y-intercept is minus 2 pi. So this is x minus 2 pi. Here slope is minus 1. So this is y is equal to minus x. And y-intercept will be 4 pi. So I put here plus 4 pi. So this is y is equal to minus x plus 4 pi. The next line will be y is equal to x minus 4 pi and so on. On this side, this is y is equal to minus x. This is y is equal to x because slope is 1 and the y-intercept will be 2 pi. So this is x plus 2 pi. This is y is equal to minus x because slope is minus 1, and if I extend this, the y-intercept will be minus 2 pi. So I write here minus 2 pi. This is y is equal to x, slope is 1, and if I extend this, the y-intercept will be 4 pi. So this is x plus 4 pi. On this, if I consider x is equal to 8, 8 will be somewhere here. This is 3 pi, 9.42, so 8 will be here, and for 8 we have y is equal to 8 minus 2 pi. So अभी हमने थोड़ी देर पहले निकाला था cos इनवर्स cos 8 का वैल्यू क्या होता है 8 minus 2 pi. Okay, there was a question in JEE Advanced 2014 based on this graph. The question was how many roots this equation has. Cos inverse of cos x is equal to 10 minus x upon 10, where x belongs to 0 to 4 pi. इस इक्वेशन के कितने रूट्स होंगे when x belongs to 0 to 4 pi. Now for this types of equations we consider graphical method. We draw the graph of two functions, y is equal to cos inverse of cos x and y is equal to 10 minus x upon 10, which is straight line, and we find the number of points of intersection. We have already the graph of cos inverse of cos x. To draw the graph of this function y is equal to 10 minus x upon x, I write line like this, y is equal to 1 minus x upon 10. Okay, let's draw this line. For that I will consider x is equal to 0, so y is equal to 1. We have 1 approximately here. This point is 0 comma 1, and when y is equal to 0, the value of x is 10. So x intercept is 10. 10 is approximately here. Now I draw line joining this 2 points. So I have this line. Okay. Now how many points of intersection? I have to consider x belongs to 0 to 4 pi. The number of points of intersection are, this is 1, 2 and 3. So there will be 3 points of intersection, hence 3 solutions. So to answer this types of questions, graphical method is always advisable. We can